So, solution of a linear equation. Now, in our previous classes, we have seen that a linear equation in one variable has a unique solution, and we have seen the methods how to solve such a linear equation in one variable. But now, as we are studying about linear equation in two variables, now is it possible to find a solution to such an equation, or how to solve such a linear equation in two variables? So that's something we are entirely going to discuss in this lecture. That is the solution of a linear equation in two variables. Let us, for example, consider an equation 4x minus 3y equal to 16. Now this is a linear equation in two variables, that is x and y. Now, if we put x equal to 7 and y equal to 4 in this equation, as this equation has two variables x and y, so if we assume that x is equal to 7 and y is equal to 4, then what do we get? We see that the LHS becomes equal to 4 times 7 minus 3 times 4. Now 4 into 7 is 28 and 3 into 4 is 12. So 28 minus 12 is equal to 16. RHS is equal to 16. We know that. So what we see is that LHS is equal to the RHS. That is, the left hand side of this equation becomes equal to the right hand side when x is equal to 7 and y is equal to 4. And so what we can say is 7, 4 is a solution of this equation. So if we put x equal to 7 and y equal to 4, then we get LHS equal to RHS, and so 7, 4 becomes the solution of this equation 4x minus 3y equal to 16. Now, let us say that if we put x equal to 0 and y equal to minus 16 by 3, then what happens? So if we take x equal to 0 and y equal to minus 16 by 3, then the LHS of this equation becomes equal to 4 into 0 minus 3 into minus 16 by 3. This becomes 16 minus 0, and this is equal to 16. Also the RHS is equal to 16. Here we can see that. So again the LHS is equal to the RHS, and so we can say that 0 comma minus 16 by 3 becomes the solution of this equation, because when we put x equal to 0 and y equal to minus 16 by 3, then LHS becomes equal to the RHS, and so this becomes the solution of this equation. Now again, let us say that if we put x equal to 4 and y equal to 0, now what do we get? LHS becomes equal to 4 times 4 minus 3 into 0. Now 4 into 4 is 16, and this becomes 0. So 16 minus 0 is equal to 16. Thus the LHS of this equation becomes equal to 16. Also the RHS is equal to 16, and thus we can say that again the LHS becomes equal to RHS, and so 4 comma 0 is also a solution of this equation. So what we see here is that for this particular equation there are so many solutions. Earlier in linear equation with one variable we had a unique solution, but if we have one equation in two variables, then this can have infinitely many such solutions. So if we have got one linear equation in more than one variable, then we can have infinitely many such solutions for an equation like this. Now let's see some of the important remarks. The first is, a linear equation in two variables has infinitely many solutions. So just we have seen that a linear equation in two variables can have infinitely many solutions. Not the case like a linear equation in one variable where we used to have a unique solution. Here the linear equation in two variables has got infinitely many such solutions. Now, an easy way of getting a solution is to take x equal to 0 and get the corresponding value of y. Similarly, we can put y equal to 0 and obtain the corresponding value of x. So if you are asked to find out two solutions of a linear equation, then the best way of doing is first put x equal to 0 and get a corresponding value of y. So 0 comma that corresponding value of y would be a solution of the equation. Similarly, for second solution, you can put y equal to 0 and get the corresponding value of x. So the corresponding value of x together with 0 is the solution of the required linear equation. So putting x equal to 0 and getting the corresponding value of y, and similarly y equal to 0 and getting the corresponding value of x is a very simple method of getting a solution to a linear equation. A linear equation in two variables has infinitely many such solutions, and this is a method to get two easy solutions of a particular equation. Now, the methods of solving linear equations. Now, how to solve a set of linear equations or a system of linear equations? So, there are two actually methods. The first method being the graphical methods, and the second being the algebraic method. So if we have to solve system of linear equations, then there are two methods. Either we can do it graphically or we can do it algebraically. In your further classes, you will study about these methods in more detail. How to actually find the solution of a system of linear equation using the algebraic methods and the graphical methods. Now the solutions of linear equations. Now we are talking about a system of linear equations and how to find a unique solution to such system of linear equations. When the number of equations is the same as the number of variables, there is likely to be a solution, not guaranteed but likely. So whenever we have a number of equations or a system of equations such that the number of variables involved is equal to the number of equations given to us, then there is likely to be a solution. It's not guaranteed, but it's likely. This is possible situation. So if the number of variables is equal to the number of equations given, then there is likely to be a solution. But on the other hand, if the number of variables is more than the number of equations given to us, then we cannot find a solution to such system of linear equations. Now there are three cases for such a situation. So if we have a system of linear equation, let us say that we have got two equations and two variables. Now there are three cases for this. The first is that the two equations do not have a solution, so the condition of no solution exists. The second is the condition of one solution exists, that is, there is a unique solution to the set of two linear equations. And the third condition is there are infinitely many such solutions to that set of two linear equations. So if we have got a set of two linear equations in two variables and we have to solve it, now there are three cases. The first is a case of no solution, that is, there exists no solution of these two equations. The second is there is one solution or the unique solution, and the third is there are infinitely many such solutions to such a set of linear equations. When there is no solution, then it is called as inconsistent solution. So the case when no solution exists, we call it as inconsistent. And the case where one solution or infinitely many such solutions exist, then we say it as a consistent system. So when we have no solution for a system, then we call it as inconsistent, and when we have one solution or infinitely many solutions, then we call it as a consistent system. So this was about solutions of linear equations. Now let's see a case where there are two equations and two variables. So for such a case, again there are three such cases for a solution to exist. Either it could be no solution, it could be a unique solution, or it could be infinitely many such solutions. So we can represent such situation by this figure. The case where no solution exists, we get two parallel lines. A linear equation represents a straight line. So there are two straight lines. But when there is a case of no solution, we see that these two lines do not intersect each other. That is, they are parallel to each other. So when the two linear equations represents two parallel lines, then we can definitely say that no solution exists for such a system of linear equations. The second is that the two lines intersect at a point, and this point of intersection is actually the solution, and so this is known as one solution. And if both the equations represents the same line, that is, these two lines are coincident with each other, then there are infinitely many such solutions, because every point on first line is also the point on the second line, and so they intersect infinitely at many points, and so there are infinite solutions. So we call this system as inconsistent, and we call these two as consistent system. Now what are independent and dependent, we are going to see it later. So for now we can say that when the equations represents two parallel lines, then the system has got no solution, and it is called as inconsistent. When the equations represent two intersecting lines at a point, then the point of intersection is called as the solution, and so there is only one point of intersection, and thus there is one solution. And when the two equations represents the same line or the coincident lines, then there are infinitely many such solutions for this system of equations, and these two together are known as consistent. In your higher classes, you are going to study about the condition of no solution, one solution, and infinitely many solutions in detail. For now, it is sufficient for you to know that what do we mean by a condition of no solution, what do we mean by a condition of one solution, and what do we mean by a condition of infinitely many solutions. Now, independent and dependent equations. Now, what do we mean by independent and dependent equations? So first, let's try to understand what are independent equations. Independent means that each equation gives new information. Here we have two different equations. So the word independent means that each of the two equations gives us a new information. So we are in a position to find out a solution to such a system of equations. So we can say that here we have two different equations. For example, let us say that 3x minus 2y equal to 4 is one equation, and the other equation is x minus y equal to minus 2. Now these two are independent. So because each of these two equations gives us a new information, and based on this we can find out a solution to such a system. So independent means that each equation gives us a new information, or each of the two equations are different from each other. So this system is known as independent equations. Now let's see what are dependent equations. Dependent means that each equation does not give a new information. It is just the contrary of independent. Here we have two identical equations. So two equations which are identical to each other are actually dependent equations, and these two equations do not give us a new information. For example, if we have an equation 3x minus 2y equal to 4, and we have another equation 6x minus 4y equal to 8, then these two equations are dependent because actually these two represents the same situation or the same equation. If we multiply this equation by 2, what we get is 6x minus 4y equal to 8, and thus these two equations are actually the same, and so they are known as dependent equations. Now, why we use algebra when graphs are so easy? We have seen that drawing a graph is actually very easy and interesting. Then why do we use algebraic methods to solve a system of linear equations? This is because more than two variables can't be solved by a simple graph. So we have seen that drawing a graph is easy when there are two variables, or we have to solve it two-dimensionally. But as the number of variables increase, then it becomes very difficult to draw the graphs of such linear equations and then solve them. So in such situations where the number of variables are more than 2, we prefer using algebra because it makes our work easier. Now, enough of theory. Let's try to solve a few examples. Find 4 different solutions of the equation 2x minus 5y equal to 14. So we have been given an equation 2x minus 5y equal to 14. This is one linear equation in two variables x and y, and we have to find out 4 different solutions of this equation. So let's see how to solve such a problem. The given equation is 2x minus 5y equal to 14. So this is a linear equation in two variables x and y, and we have to find out the solutions of this equation. Now we know that there are infinitely many such solutions for this equation. So the first is, let us put y equal to 0. So the simplest way of finding a solution is put y equal to 0. So when we put y equal to 0, what we get is 2x equal to 14, and thus x is equal to 7. So 7 comma 0 is a solution to this equation, because if we put 7 comma 0 over here, we get the LHS equal to RHS, and so 7 comma 0 becomes a solution to this equation. Similarly, we can put x equal to 0. Now when we put x equal to 0, what we get is minus 5y equal to 14, or y equal to minus 14 by 5. So x equal to 0 and minus 14 by 5 is actually a solution to this equation. Now if we put x equal to 12 and y equal to 2, what do we get? We get LHS equal to 2 into 12 minus 5 into 2, which is equal to 14, and RHS is also equal to 14. Thus we can say that 12 comma 2 is also a solution to this equation 2x minus 5y equal to 14. And the fourth is, let us put x equal to 17 and y equal to 4. Now what do we get as LHS? LHS would be 2 into 17 minus 5 into 4, which is equal to 14. So LHS is equal to 14 and RHS is also equal to 14. Thus 17 comma 4 is also a solution to this equation. So the four solutions to this equation are 7 comma 0, 0 comma minus 14 by 5, 12 comma 2 and 17 comma 4. Important point to notice, as we know that this equation has infinitely many such solutions, so you can find many other solutions. So put x equal to 1, 2, 3, 4 and so on and get the corresponding values of y. The values of x and the values of y obtained would be a solution of this equation. Let's try to solve one more example. If x is equal to 3r minus 4 and y is equal to r by 2 is a solution of the equation 4x minus 3y equal to 5. Find the value of r. So in this problem we have been given that x is equal to 3r minus 4. Here we do not know the value of r, so r is also a variable. So x depends on r. And similarly y, which is a variable, is also dependent on r by the equation y equal to r by 2. And x comma y is a solution of this equation. We have to find out the value of r. So given to us that x is equal to 3r minus 4 and y is equal to r by 2 is a solution of the equation 4x minus 3y equal to 5. Now replacing x by 3r minus 4 and y by r by 2 in this equation, if we replace x by 3r minus 4 and y by r by 2, what do we get as 4 times 3r minus 4 minus 3 times r by 2 equal to 5, which could be further written as 12 times r minus 16 minus 3r by 2 equal to 5. Now 12r minus 3r by 2 is actually equal to 21r by 2, and when we take minus 16 to this side, what we get is 21. So 21r by 2 is equal to 21. 21 and 21 gets cancelled, and what we get is r equal to 2. Thus the value of r comes out to be equal to 2. Thus the value of r comes out to be equal to 2, and so we have solved this problem. Let's try to solve one more example. Find the solutions of the form x equal to a, comma y equal to 0 and x equal to 0, comma y equal to b for the following equations 2x plus 3y equal to 18 and 4x plus 2y equal to 12. Now is there any common solution? So in this problem we have been given two equations and we have to find the solutions of the form x equal to a, y equal to 0 and x equal to 0, y equal to b for these two sets of equations. And then further we have to see that is there any common solution to both these equations. So let's try to solve it. Given to us are two equations 2x plus 3y equal to 18, 4x plus 2y equal to 12. So we have been given two linear equations in two variables, this and this. Now let's look at the first equation, which is 2x plus 3y equal to 18. We have to find a solution of the form 0 comma b. So for that, if we put x equal to 0, then what we get is 3y equal to 18 or y equal to 6. Thus we get 0 comma 6 as a solution to this equation, and this is of the form 0 comma b. Similarly, to find a solution of the form a comma 0, that is y should be equal to 0. So putting y equal to 0, what we get is 2x is equal to 18 or x is equal to 9. Thus 9 comma 0 would be a solution of this equation 2x plus 3y equal to 18. Thus we get the two solutions of 2x plus 3y equal to 18 as 0 comma 6 and 9 comma 0, and these are of the form a comma 0 and 0 comma b. Now let's look at the second equation, which is 4x plus 2y equal to 12. Let us put x equal to 0. So when we put x equal to 0, what we get is 2y equal to 12 or y equal to 6, and so we can say that 0 comma 6 is a solution of this equation, and it is of the form 0 comma b. And to get a solution of the form a comma 0, what we do is we put y equal to 0. So when we put y equal to 0, what we get is 4x equal to 12 or x equal to 3. Thus, what we get is 3 comma 0 as a solution of this equation. Thus 0 comma 6 and 3 comma 0 are the solutions of this equation 4x plus 2y equal to 12. So this is the first part of the problem and we have solved this. Now in the second part we have to see that is there any common solution to both these equations. Now we can clearly see that 0 comma 6 is actually a common solution to both these equations. So 0 comma 6 also satisfies this equation and 0 comma 6 also satisfies this equation. So the common solution to both these equations is 0 comma 6, and which is actually the point of intersection of both the lines represented by these equations. Thus 0 comma 6, 9 comma 0 are the solutions of 2x plus 3y equal to 18, and 0 comma 6 and 3 comma 0 are the solutions of 4x plus 2y equal to 12. Further, we see that 0 comma 6 is a common solution to both these equations. So this was all about how to find out the solutions of a linear equation.